Lesson 4.8, Analyzing Graphs of Polynomial Functions. Our essential question, how do you find turning points, local max or min, and if they're odd or even functions? First, we have a couple of definitions that we need to make sure that we know that they're all equivalent. The zero, the factor, the solution, and the x-intercept, when you are asked to find all of these, they're essentially the same exact thing. The zero of the function, to find the solution of the function, they are the same exact thing. What are they? They are the x-intercepts of the function. How do you find that? By finding the factor of the function. All four of these are equivalent terms. So we're now being asked to use x-intercepts to graph the polynomial function. And here we are given the polynomial function. Because this has an exponent of a 2 on it, I'm going to go ahead and expand it so I can see what my full function is. So I do have my function f. Exponent 2 meant this parenthesis was twice. So I have the 1/6 x plus 3, and then this x minus 2, I need to have 2 of them. So this is my full function. When we are being asked to graph a function, the very first thing that we need to identify are what are our end behaviors. And you determine the end behaviors by looking at the highest degree and the leading coefficient. The highest degree. Looking at this, we're already in factored form, so the highest degree is found a little bit differently. Remember, your degree also told you how many solutions you would have found, which would have also told us how many factors we would have had. So because I see 3 factors, I know that my degree is 3. My leading coefficient is the 1/6. 1/6 is a positive number. Degree of 3, that meant I had an odd degree. So I need to look at my 4.1 chart to figure out what does odd positive look like. Here's my 4.1 chart. Odd positive is right here. So I'm down on the left and I will be up on the right. So I'm down on the left and I believe that I am up on the right. After I know what my end behaviors are, we need to find the zeros, which is finding the solutions. We're going to do that by factoring. So our equation is 1/6 x plus 3, x minus 2, x minus 2. This was our function. Our function had to equal 0 for us to find our zeros. Now it's already fully factored. So every single factor is going to give us an equal 0 statement. 1/6 does not equal 0. There is no variable in here, so he does not give us a 0. Solving for x on all of the other terms, I found 3 answers for x, which I should have because my degree was 3. How many answers you find is the same exact degree that you should have had. Because I see that my 2's are repeating. Remember, a repeat is a touch and go. So he's not going to go through the number 2. He's going to touch it and run away. He'll go through the -3 though. So let's go ahead and get our XY axis drawn. We need to scale it. So -3, I cross the x-axis and -3. I should touch and run at the 2. These are my x-intercepts. My end behavior said this last one went down and this right one went up. Now I need to know what goes on in between, and that's what we're learning today. Today we are going to find out what goes on in the middle. So we're going to find out the middle by using an XY chart. I know what happened at -3. I want to know what happened at -2, -1, 0, and 1. All of the x's between my intercepts. So I know what happened at -3. -3 gave me my 0. I know what happened at 2. 2 gave me my 0. Those are the x-intercepts. I want to figure out what happened between. So I need the -2, the -1, the 0, and the 1. These are the values that I need to find. So I am going to plug these values into the original f function. When I do that, -2 gives me the answer 2.66666666. -1 gives me the answer of 3. 0 gave me the answer of 2. 1 gave me the answer of 0.666666. So now I finally know what actually happens between these. Negative 3, 0 was already plotted because he was one of our x-intercepts. Negative 2, 2.6, he's going to be about right here. Negative 1, 3, he's going to be about right here. 0, 2, 1.6. So I can see that my graph looks like this, and I had to make sure that it was a touch and go because he was a repeat. And I finally have the fully complete Desmos looking graph. So let's go ahead and look at problem number 2. I'm being asked to graph. If I'm being asked to graph, then the very first thing that I need to look at are my end behaviors. So I need to find my degree and my leading coefficient. Because this appears to already be in fully factored form, our degree is found a little bit differently. Our degree is the same as how many times I crossed the x-axis, which is the same as how many factors did you find? I found 3 factors, so I know my degree is a 3. So because my degree is a 3, 3 is an odd number, so I know my degree is odd. The leading coefficient is still the number 1/4, and number 1/4 is a positive number. So I'm going to have to look at my lesson 4.1 notes to figure out what does an odd positive function look like. Here's my lesson 4.1 chart. An odd positive function looks like this. I'm down on the left and I am up on the right. So my little demo example, I know I'm down on the left and I am up on the right. After our end behaviors, step number 2 is to find our zeros, or find the x-intercepts. Where does it cross the x-axis? So my function had to equal 0, so the f of x is 0, and this is what the function was. We're supposed to fully factor and then solve for x. It already is in fully factored form. So now every single one of these factors is going to equal 0, and we're going to solve for x. Because there's no x variable here, you can't solve for x, so he is not a 0. I found 3 answers, and I know I was supposed to find 3 answers because my degree is 3. The number of the degree will match the number of solutions that you found. So now I need to make an xy axis. We're going to go ahead and scale our x's. I cross the x-axis at -2. I cross the x-axis at a +1, and I cross the x-axis at a +3. None of these are repeats, which means I have to go through every single one of these points. My end behavior said this last left point is down, and this last right point is up. Now I just want to know what happens in between. So step number 3 that we're officially now allowed to do is to find out the middle. And we find out the middle using your XY chart. We know these 3 points. I need to figure out what happened between and between. So I had the point -2, 0. I need to know what happens all the way to the last one at 3. So I want to figure out what happened at -1, 0, 1, 2, and 3. I already know what happened at 1. I landed on the x-axis. I already know what happened at 3. I landed on the x-axis. So I only have 3 more points that I need to find. So we're going to use our calculator. This is the function that we're supposed to use and plug these x values in to figure out our y. -1 plugged into this function will get you the number 2. 0 plugged into this function will give you the answer 1.5. 2 plugged into this function will give you the answer -1. So we just need to plot those points. -1, 2, so we need to make sure we scaled our y-axis. So -1, 2, 0, 1.5, 1, 0, 2, -1. So I have all of those. I am now going to connect my graph, connect all the points that I found, and now my graph officially looks like the Desmos graph. You have one problem left on the page. We're going to have you do this problem for independent practice.